Let us start exercise 1.1. Now before starting the exercise, if you have gone through my other lectures of algebra or other lectures of geometry, one thing let me very clear that I am not going to solve each and every problem here. But we are going to discuss all the problems. We are going to discuss how to solve the problems, and then I will tell you the answer for that, which you can check with you. Second thing, I am not going to tell you the each and every step of it. That means statement number 1, the reason is this, statement number 2, reason is this. Why? Because you should not have habit of spoon feeding. Let me tell you one thing, there is no specific rules and regulations for how to solve the particular example or what are the particular steps. One student may solve that example in 3 steps, another student may solve that example in 4 steps. Okay? So only thing you have to do is, whatever you are going to do, suppose you are going to add some construction to it, just mention whatever you are going to do. There is no hard and fast rule. So the simple thing is, first write down the given or draw the rough figure, write down the given. Okay, if you are doing any construction, mention that. If you are naming any angles to alpha, beta or something, mention there, and then solve the example. And then for the every step, if you are doing something, then give that particular reason. Okay, so let us solve the first problem. 1.1 is very simple, but let us do it. So the first example is, in the figure is given something like this. In the figure, segment BE is perpendicular to segment AB and segment BA is perpendicular to segment AD. If BE is 6, if this is 6 and AD is 9, then we have to find the area of triangle ABE and area of triangle BAD. We have to find this ratio. That means we have to find the ratios of area of these two triangles. Very simple example. It appeared for 1 mark in October 13, October 14, July 15. So generally 1 mark for 1 mark question, it is very simple. We know that, we already know that. Here I am going to solve this problem. We know that, let us say, or you can say that, let the area of triangle ABE is A1 and let the area of triangle BAD is A2. Why we have to write this? You can write that, you can write like this, area of triangle ABE and all. Okay, you can write like this because there are only 2 steps here. But suppose the problem is longer, lengthier, then what you'll do? Every time you have to write this, every time. So instead of that, initially I am declaring that area of triangle ABE. I am writing that statement. You have to write that statement, that let the area of triangle ABE is A1 and area of triangle ABD is A2. So the ratio is so and so. So the area of triangle, this is A1, A2, we have to find A1 upon A2, this ratio we have to find, and we know from the properties that the ratio of area of triangles is equal to the ratio of product of their base and height, corresponding heights. But here you can see these two are right angle triangles and this height is common for both. So if this is equal to B1 H1 upon B2 H2, since height is same, it will get cancelled, and this is nothing but B1 upon B2, which is nothing but 6 upon 9 is equal to 2 upon 3. So in the answer, so A1 upon A2 is equal to 2 by 3. But in the answer, you have to write again what they have asked, in the format they have asked. So you have to write that, like I shown you here, area of triangle ABE, ratio of area of triangle to the area of triangle ABD is equal to 2 upon 3. This you should write as an answer. Okay. So this was very simple example. Actually, I didn't want to solve everything here. Just to show you, always remember that your equal to sign must come below your equal to sign. You have lot of space on your paper. Okay, so don't write or don't solve anything congested. Use full width of the paper. Okay, draw rough figure, declare whatever you are assuming, and then solve. And at the end, write down the answer and also highlight that answer with the pencil or pen, whatever it is. Don't use your rulers and draw the rectangles over there. You can just by hand. See, by hands drawing straight line is something difficult, but you can do something like this. Suppose I don't want to draw the straight line, what I'll do, I'll draw the zigzag lines. This is easy to draw. Okay, because while drawing straight line it will go up and down, it will not look nice. But zigzag line, it is zigzag line, so it won't look very bad. So at the answer you have to highlight the answer. If they have given, now in this case they have not given any units, only 6 and 9 they have given, correct? So if they are given centimeters, then you have to write centimeters. They have given meters, then you have to write the meters in your answer. But for the ratio, there are no units. The ratio is denoted by the single number. Okay, so in this way we are going to discuss the problem, and you are going to solve the problem here and here itself by pausing the video in between. Okay, so let us go to example number 2 in 1.1. Example number 2 of 1.1. The figure is given something like this. Don't look at neatness of my figures. I am drawing figures with my hands. But even if you are drawing the rough figures, use proper geometrical instruments. Okay, use ruler. If you want a compass, in case of your circle, use the compass, use ruler. Draw proper figures. Here I am drawing figures with my bare hands. Okay, so this figure is really a rough figure. Let us read the problem. In the figure, segment SP is perpendicular to side YK. Segment SP is perpendicular to side YK. This is the triangle, this side. Then segment YT is perpendicular to side SK. YT is perpendicular to side SK. If SP is 6, SP is given 6, YK is 13, YK is 13, then YT is 5, YT is 5, and TK is 12, TK is 12. Then find the ratio area of triangle SYK, area of SYK upon area of triangle YTK. Now here we have to find out the ratio of area of triangle SYK. What is SYK? S, Y and K. This is one triangle. And YTK is another triangle. So we know that it is B1 upon H1 and B2 upon H2. This ratio is equal to the ratio of their base and height. So for SYK, what is the base? Is 13. What is the height? Is 6, because height is always perpendicular to the base. In YTK, what is the base? This is the base. And what is the height? This is the height. So just B1, H1, B2, H2 are given. You can easily find out the answer. Please pause your video and complete this. I am not even going to tell you the answer of this. Just check in your books. At the end of your books, the answers are given. Just check the answers, because this is very, very simple problem. Okay? Please pause your video and solve this problem. Example number 3, the figure is given. Let us read the problem. If in the figure RP is to PK is equal to 3:2. RP is to PK is equal to 3:2. Find the values of following ratios. And now here you can see 3 triangles. One is this triangle, second triangle, and then this bigger triangle. So they have asked the ratios of different triangles. That means first of all, this triangle, area of this triangle, and the ratio of area of this triangle. That means area of this triangle upon area of this triangle they have asked. Then they may have asked the area of this bigger triangle to this smaller triangle, and then this bigger triangle to this triangle. So the three ratios they have asked, and here they are not given any measurement of the sides, but they are given RP upon PK is 3:2. Okay, so you can see that for these all three triangles, the point vertex T is common. So the height of all these triangles are same. Now here it may look like right angle, but it is not right angle because they have not mentioned it. Okay, even though the figure looks like a right angle, that doesn't mean that it is right angle. Only if they have mentioned that this side is right angle, only then you can consider that yes, this is height. Otherwise, just by visual appearance, don't consider this is a height. So here I will, first of all, here I will consider RP is equal to 3x. If RP is equal to 3x, then PK is equal to 2x, because they are 3:2. So I can say that this is 3x and this is PK is 2x. And we know that when the height is same, the ratio of area of triangle is equal to the ratio of their corresponding bases. So if this triangle is there, the base is 3x. If this triangle is there, the base is 2x. And if this bigger triangle is there, the base is 3 plus 2, that is 5x. 3x plus 2x, that is 5x. So you can find all three ratios. So please pause your video here and find out the ratios quickly. This example was also for 1 mark in March 14 exam. Just 1 mark, you have to find three ratios. Example is very simple. Okay, please pause your video and do it. Problem number 4. Figure is not given. The ratio of the areas of two triangles with the common base. Now with the common base, that means what will be the ratio of areas of those two triangles? Will be equal to ratio of their heights, corresponding heights. Let us read it again. The ratio of areas of two triangles with the common base is 6:5. The height of the larger triangle is 9 cm. Find a corresponding height of the smaller triangle. This example was for 3 marks in March 15 exam. 3 marks. So as they have stated for the larger triangle and smaller triangle, I will write that area of larger triangle upon area of smaller triangle is equal to height of larger triangle upon height of smaller triangle. This is by property. Then they are given the ratio of areas of two triangles with the common base is 6:5. Here they are already given, it is 6:5. This is already given. Then the height of the larger triangle is 9 centimeters. The height of larger triangle is given 9, and you have to find the height of the smaller triangle. Extremely easy example. 6 upon 5 is equal to 9 upon HS, and you have to just find out the height of the smaller triangle. Answer is very simple. Pause your video, solve the example. Don't forget that they have given the height of the larger triangle is 9 centimeters. So when you find the answer of this, you have to write the answer unit also centimeter. If you forget to write the unit, your half mark or 1 mark will cut straight away. Okay, so very simple example for 3 marks. Let us go to next example. Example number 5. The figure is given something like this. In the figure, segment PR is perpendicular to side BC, AS is perpendicular to side BC, and QT is perpendicular to side BC. These three are perpendicular to BC. Okay, so now many triangles you can see here. ABC bigger triangle, then this smaller triangle, then this triangle is there, this triangle is there. Many triangles are there in this case, and everywhere height is given. Okay, now what we have to find the following ratios. Area of triangle ABC upon PBC. ABC bigger triangle upon PBC, this triangle. Now here you can see the base is common, height is different. So the ratio of area of these two triangles is AS upon PR, and similarly you have to find the ratios of ABS upon ASC, ABS this triangle upon ASC this triangle. Now in this case base are different but the height is same. Third is PRC upon BQT, PRC, that means this triangle upon BQT. So here you have to write in the form of base into height upon base into height. Now again I am telling you, in the figure it looks like this PR and QT are of same length, same distance, same length. But if they are not given that, you should not consider they are of the same length. Okay? So here your answer will be base into height upon base into height. The fourth is BPR upon CQT. BPR, this smaller upon CQT, this smaller triangle. Now here also base into height upon base into height. Don't consider that these two heights are same because they looks like same in the figure. Unless and until they are given, they are stated that these heights are same, you should not consider by yourself. Okay? So this example was very simple. You have to write the ratios. Let us go to the sixth example. Example number 6. The figure is given. In the figure, these two triangles are given, and this is the DH is perpendicular to EF and GK is perpendicular to EF. These two triangles are there. Obviously, this DH is the height of this triangle above, and this GK is the height of this triangle below. Okay? Now they are given that if DH is 12 they are given, GK is 20. Now here they are given centimeters. I am not writing centimeters unit here, but in the answer we have to write the unit. And the area of triangle DEF, area of triangle DEF is equal to 300 centimeters square. Then find EF, we have to find the length of EF. Then area of triangle GEF, this triangle below area we have to find out. And the area of quadrilateral, this quadrilateral, that we have to find. This is very simple example because they have given DEF, area of triangle is given. What is the formula for area of triangle? Half base into height. In this case, area is known, height is known, you have to find out the base. So EF can be easily find out. Once you find the EF, then they have asked what is the area of this triangle. You know base, you know height, you can find the area of this lower triangle very easily. And this quadrilateral is nothing but the addition of the areas of both the triangles. So 300 plus whatever be the area of this triangle, you have to add. This is again very simple example. Just you have to use your formula for area of triangle here. Okay, nothing difficult in this. So please pause your video here and solve this example. First find out the length of EF, then you find out the area of this triangle, then add both the areas and find out the area of the quadrilateral. So please pause your video and solve this example now. Example number 7, this figure is given. In this figure they are given ST is parallel to QR. That means ST and QR, these two lines are parallel to each other. Okay, what do you mean by that? The distance between these two lines at any place will be same. Okay, then they have asked us to find the following ratios, that is PST upon QST, area of triangle PST upon area of triangle QST, PST and QST. Okay, now vertex is common, one point is common in this PST and QST. When one point is common, that means the height for the both the triangles is common. So their ratio of their areas is equal to the ratio of their bases. So here the base is PS here of one triangle and QS is of another triangle, because the point T is common. Okay. The second, PS area of triangle PST upon area of triangle RST, PST upon RST. Now in this case also point S is common, just like here T was common, here S is common. So for this triangle the base is PT and for this triangle the base is TR. So the area of these two triangles, the ratio of area of these two triangles is equal to the ratio of their bases. The third we have to find out area of triangle QST upon area of triangle RST. QST and RST. Now in this case, can you see that these two are parallel lines? That means the height of these both the triangles is same and the base is common. ST is common for both the triangles, and when you are taking the ratios of areas of two triangles, when their base and height are same, the ratio is always equal to 1. So you can write this property, or you can directly write down that the area of triangle this upon area of triangle this equal to ST upon height. Height is same and base is same, so the ratio is 1. So please pause your video and solve this problem. Write down the ratios properly, write down as an answers, and with this problem we are finishing the exercise 1.1. It was very simple. Actually, no need to even discuss these problems here, because those are depend on just one property, that is the area, the ratio of the area of triangles is equal to ratio of the product of their base and height. So here we are finishing exercise 1.1. Thank you.